Hello everyone, welcome back to the course of Finite State Machines. This video is brought to you by Newton's Group of Institutions, Macherla. This is Y.N.D.Aravind from the Department of Computer Science and Engineering. Today in this video, let us discuss how to draw a transition diagram for a Turing machine. Now let us see how to draw an transition diagram for a Turing machine by taking a simple example of a power n, b power n, where n is greater than or equal to 1. The same example we have discussed in finite state machines and push down automata. And since Turing machines is more powerful than finite state machines and push down automata, we can do it in Turing machines also. Now, let us see the working mechanism for this. How our Turing machine is going to work for considering an example string like this. So we are taking an example of AAA followed by BBB, and in starting and ending we are placing with blank symbols. As we know that the Turing machine is having infinite sequence on both ends, and we can move towards left or towards right. So now we have to process this storing AAA followed by BBB. So please do understand, I don't have any direct method for counting 3 A's first, then counting 3 B's next. Then what we do? First we count 1 A, then we go forward. For this A, we want the corresponding B, and we have to match 1 by 1. Then again come back, count second A, then again go forward to count the second B. So if our comparison 1 to 1 is valid, if the number of A's and number of B's are same, now here my question is how to identify which A and which B we have already counted, and which A or which B still we have to count. For this, the concept is very simple, because this is the Turing machine which has an header which can move towards the right and the left. And this header is both the read header and write header. So for which every symbol we read to replace with, say whenever I read A, I replace it with X. And whenever I read B, I replace it with Y, say. So to make it sure that which is processed and which B is processed and which A or B is unprocessed, now let us start our process. Say we have started from an initial state Q0. Now whenever we read first A, then we have to replace it with X. Then we go in forward direction until we read its corresponding B. Since we have to see the number of A's and number of B's are same or not. So now let us start the game. Let us change the state. And here why we are changing the state is to make sure that we have read the minimum strings and going forward. So now let us see how a transition is on state Q0. So we read a symbol A. After reading, we are replacing it with X to make sure that we have processed it. Then putting comma, we write the symbol with which we have replaced. And then let us write R, which means we have made a right move. As we have already discussed that in Turing machines, it is important to say whether we have moved left or right. So when we move right, then our header will move here. So here the meaning, if on Q0 we get an input A, then we rewrite with X, and after rewriting we move towards the right and come to state Q1. So now our header is at this particular A. Now our header is at this particular A. Okay. Then what we have to do? We have to count or leave. So we have to leave it since already we have counted one A. Now we have to count its corresponding B. So there is no need to change the state since logically it states that we need to go forward until we find the corresponding B. So let us draw the loop such that if we find A, then we replace it with A and move right. So place. So we need to understand how we are writing the transition. If you don't want to really move right, then whatever the symbol you read, you have to write the same symbol again. Okay, you have to write the same symbol again, and you have to move towards the right. Okay, so logically it means that you have not performed any right. So this is same thing like skip operation. So it will skip twice, and like this our header will reach to this point at B. Okay, so for the second time what we do, we change the state, and suppose that we have reached to state Q2. Now we have read B, so we have read the B. So on B we replace it with other symbol to make it sure that we already processed it. So we replace it with Y. Now we have to move which direction? We have to move towards right or left. We have to move backward direction. So here we have to move towards the left. So for 1A we have converted 1B. So the direction we have to take is left. So once again we need to repeat this cycle. So we replace this B with Y and we move to left in state Q2. Okay, so if you would have understood the process, now we are at state Q2 with symbol A, and we need to travel back, that is left, without processing the A and until we reach the X. So we have to come in the back direction until we find the X. So now can you say what we have to do? We have to reach till X. Since once we come to X, we will understand that this is that X what we have already processed. And then once again we have to start the game. So we have to come back until we don't find the X. So how can we do this on state Q2? We draw the loop such that if we find A, then we replace it with A and then we move towards the left. So this is the process what we have to do. So finally what we do? We reach to state X. So we reach to state X. So whenever we reach to X on state Q2, then once again we need to come to the state Q0 without doing anything to X. So X replacing with the X only and move towards the right. So we have to move towards the right. So now our header will once again move to the right to make the second fight once again. So whenever it find A on the state Q0, what is going to do? So it will convert the A to X. So whenever we find on state Q0 A, it will convert to X and it will move right. So it will convert it to X and it move to right. Now we have come to state Q1. Now we have come to state Q1. So on state Q1, if we find A, then we replace A with A and move right. So we have when we find A, we replace A with A and we move right. So here now after moving forward to we got Y. So this is the first time it is happening that when we are going forward we got Y. So is this Y we have to process or it is been already processed? So this Y was previously B which we processed and changed it to Y. So this Y there is no need to process. So now we have to write one more new transition. So Y on finding on the way, we have to replace Y with Y and move towards the right. So we have to, when we find Y, we need to replace Y with Y and we need to move towards the right. So finally we reach to B on the state Q1. So with B, we have written the transition before only. So with B as input, we replace it with Y and we go to the state Q2. So now this B we replace with Y and tape header moves one step left. So now again for this first time on state Q2, we are seeing Y. So Y as a input. So on state Q2, Y as input, there is no need to process because this is the Y which we processed before. So we have to write one more new transition on state Q2. So Y on finding on the way, we have to replace it with Y and move towards the left. So again, we reach to A on state Q2. So with input A, so on state Q2 with A as input, we move left until we find the X value. So now on state Q2 with X as input, we go to state Q0, replacing X with X, only moving towards the right. So now again in state Q0 with A as input, we are replacing A with X and we are moving towards the right. Now in this way, you move forward and finally you go to B. And this B will get replaced with X and more left until we find the, and we need to move left until we find the X. So on state Q2, if we find X, then we go to state Q0 by replacing X with X and we need to move towards the right. So now on state Q0, if we find A, then the same procedure repeats. And if we find Y, then what we have to do? We have to go to the new state, say Q3. Y replaces Y with Y and move towards the right. So we move towards the right. And on state Q3, if we find a blank, then we need to move to the accepting state. And if we don't find blank, if we find Y, then what we have to do? So if we find Y, then we have to take a loop and we need to stay there itself. So the process will not move forwards towards the right direction. So until we find the blank, what we have to do? We have to move towards the right. So once when we find blank, then we go to the accepting state. So by moving Y with blank with the blank and we move towards the right. So our cursor will be pointing, placing blank with blank, it will be moving towards the right. So now my question is this machine deterministic or non-deterministic? Of course, it is a deterministic because no state we have made with multiple moves. Now in this machine, is this machine complete? Yes, this machine is complete. So this is our final Turing machine in which number of A's and number of B's are same. And we call it as an state transition diagram. Now, this machine can be represented by using the transition table which I have represented here below. So by seeing this, I have developed a transition table. So this is very easy how you can draw a transition diagram. That's all for now. Thank you. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you, one and all.